Hello everyone, my name is Thomas Kim. Today is July 1st, 2019. This is my 34th episode about the future of C++ programming, C++ 2A standard. In this episode, we will talk about object ownership, lifetime, and move semantic. With C++ 11 standard, the concept of move semantic was introduced to C++ language. With move semantic, the concept of object ownership became much more important. In this episode, I will talk about the object ownership, lifetime, and move semantic. This subject is quite a lot challenging for most people, so I will divide it into two or more videos. Okay, let's get started. I start Visual Studio Code on the CPP extension Tutorials folder. Click this button 043 ownership.cpp. Hit enter. Ctrl V, Ctrl plus, include talk play fun, output HPP. Before we start, let's have some history behind C++ language. Originally, L-value reference was introduced to C++ to unburden C++ programmers from the uninitialized pointers. For example, int ptr, ints ptr, or ptr6 is the shortcut to application crash. First, note that ptr is not initialized. It can point to anything, and we are accessing an initialized pointer and assign value 5. To prevent such misfortune, C++ Standard Committee introduced L-value reference, which enforces initialization at definition as below. int reference L-value ref. Since this is L-value reference, L-value should always be initialized at the definition. Now, let's think about R-value reference. R-value reference was introduced to C++ 11 standard for move semantic. R-value reference is also a reference. That is, it should also be initialized at the definition. int R-value reference 5 or int R-value ref reference std move s. We defined s here, so it is valid operation. For your convenience, int s5. Without this move, this code does not work. Once again, without this move, this code does not work. Now let's test it. Void test R-value L-value reference ints 5 int R-value reference s. It does not work. int main. I copy this function name. I start command prompt. Please note that we should be in CPP extension tutorials folder. cl ehsc std C++17 043 ownership .cpp fe aexe. Hit enter. hit enter. Okay, it does not work. Cannot convert int to int value reference. So this is causing the problem. std move. Now it works. I will disable it and copy the pasted std move. Now it works. CLS, it works perfectly. What does it mean? std move is simply typecast to value reference. This code is exactly the same like this. int value reference. These two codes are exactly the same. Now compile once again. Hit enter. Please note that this value reference. Then what is the difference between this? value reference S. Does it work? Yes, it works. CLS, it works. What is between value reference, this line of code, and value reference, this line of code? There is no difference between line 52, this line of code, and this line of code, 54. No difference. To make sure, I will create a stream operator here. Talk play fun, SS stream, auto, NDL, talk play fun, NDL. Now here we are displaying the address of S stream, the address of S, NDL stream, the address of value ref stream, the address of value reference value ref. Now let's build CLS A. Now let's examine the address of S. The address of S ends with F600. The address of value reference ends F600. The address of value reference ends with F066, F600. All these are the same. S, value reference, value reference points to the same memory location. Once again, S, value reference, value reference are pointing to the same memory location. In this case, please read this text very carefully. The name S names an object here. The name value ref references to the object named by S. Okay, this is the S. The name S names an object on the stack. Here, the name value reference references to the object named by S. Here, the name value reference ref references to the object named by S. S, I value ref, L value ref are actually the same object. L value, R value, L value ref, and R value ref are references to S. The lifetime of the object named by S is owned by the name S. What about L value ref and R value ref? Now let's test. To understand this concept, we need to introduce a class. Class CLS type private bool and valid. We will initialize true. Public, I create the class CLS type string, CLS type cold, CLS type constant, CLS type RHS, right hand side, string, copy, constructor called CLS type R value reference. This is move constructor, right hand side, valid false, string, move constructor called, and there. Now we create destructor CLS type if valid string destructor object cleaned up, and there. Okay, I introduced this class. Now we can use this class to test. Please note that a few minutes ago, test R value L value reference here in this function, we defined integer s and initialized to 5, and we defined R value reference. This is R value reference using typecasting, and L value reference S L value R value reference L value reference. I said there is no difference between R value reference and L value reference in this configuration. Also, the address of S, the address of R value reference, the address of L value reference all refers to the same object named by S. Okay? And I said S, R value reference, L value reference are actually the same object. L value reference, R value reference are referencing to S. Okay? The lifetime of the object named by S is owned by the name S. This is very important. Okay, understanding this point is very important. What about L value reference and R value reference? They are simply reference to the object named by S. We will learn about this concept. Now here, void understand the concept of ownership. Okay, I created a function, I copy it and pasted it here. I disable it. Now here CLS type object. I created an object. I created a block CLS type. This is R-value reference. Okay, we use std move object. As I said, std move is simply typecast. As I said, std move is simply typecast. Okay, I will copy this part and paste it here. It does not work. This code does not work. This code does not work. Okay? Now let's test. It does not compile. 126. 126, it does not work. Okay? Now I disable it and enable it. Now let's compile once again. Now it works perfectly. Now another thing, CLS type. This is L-value reference. R-value REF. So this is the REF. This also works successfully. Now here I will put a message stream before entering local block, and then I copy this message and paste it here after leaving local block. Okay, I will build once again CLS A. Now watch this message carefully. CLS type called. So constructor, object constructor is called. Before entering local block, then after leaving local block, object cleaned up. This object cleaned up at this point. The object defined at line 112 is cleaned up after leaving this function block. Now let's think about this. This move is typecast. This is reference. Okay? L-value reference is also reference. Please don't get confused. Okay? In this block, both R-value reference and L-value reference are simply alias for object. Both R-value reference and L-value REF do not own the object. The object's lifetime is independent of L-value REF and R-value REF. I will rearrange this part. Please note that this does not construct. This line of code does not construct a new instance of type CLS type. This line of code does not construct a new instance of type CLS type. Okay? Now I am scrolling down. Now double check. Okay? If we compile and run this program again, I compile, CLS run again, no constructor is called. Okay? No copy constructor, no default constructor, no move constructor, no destructor is called before entering local block, after leaving local block, no constructor, no copy constructor, no move constructor, and no assignment, no copy assignment, no move assignment, nothing happens. Okay? So it is simply reference. Now let's compare with this void object lifetime of constant and R value ref. Now here CLS type object 1, CLS type obj ref std move object 1 CLS type obj2 std move object 1. I copy this function name and paste it here. I disable it. Please note that we create an object of type CLS type. So the constructor of CLS type should be called at this point. Here, please note that this is R value reference. This std move is simply typecast. At this point, obj ref is simply a reference. Std move is a typecast to CLS type R value reference. We are not creating an instance of obj CLS type. So no copy, no move constructor is called. Now this is different story. Now this is a totally different story. We are creating a new instance obj2 of type CLS type. Obj object 2 is not a reference, and we typecast obj1 to CLS type R value reference. since we are creating an instance of CLS type, a constructor of CLS type should be called at this point. Since we applied std move object1, the ownership of the object named by object1 is moved to object2. So, for your understanding, I will plug it. I will enclose in this block, okay, to make it clear. Stream before entering the local block, and then here after leaving the local block. Now I will call this function. We build once again CLS A. At this line, an object named object1 of type CLS type is created. So constructor is called. Before entering the local block and after leaving the local block. At this point, nothing happens. Because this is R-value reference. This is simply typecast. Now at this point, we are creating a new instance of object2. So a constructor should be called. That constructor is move constructor because we are using move. In this case, after move, this object1 is invalid before leaving this block because it owns. Now object2 owns the object named by object1. This object1 is defined here. Now object2 owns the object named by object1. The ownership moved from object1 to object2. At the end of this block, when object2 goes off, the object originally named by object1 is moved to object2, then is destroyed at the end of this block. Don't get confused R-value reference and std move. This is creating a new object. We are moving ownership. We are moving the ownership of the object originally named by object1. After move, object1 is invalid. Don't get me wrong. The destructor of object1 will be still called after this block. Okay, this object1, the destructor will be still called at this point. What I mean by invalid is that class invariant of object1 is invalid. Its state is destroyed or moved to object 2. I will talk more about this in my next video or in my future sessions. Before I close this session, I will give you some warnings. For it, you should be extra careful when using std move. CLS type object, CLS type obj ref object. I will create a function here, void bam looking in your code. CLS type, you can also do this. obj CLS type move the object, std move obj. Now we are calling this function like this. Bam looking in your code. obj ref sum operation. I will create the function here, void sum operation. So this code is buggy. This kind of coding fails 9 out of 10 cases. I will create another function, rvalue ref, and this is the same. I copy this code again. Now I am calling this function. Here, std move. Your program crashes 9 out of 10 cases. Why? Why these two program fails? Now we can copy this function. In current application, it will not fail. It still works in this program. 227. So I will change the function name. ref. I copied, pasted. It will not crash. It will not crash in this case. But if you code this way, your program crashes 9 out of 10 cases. std move is blind. It is a bomb lurking in your code. When you use std move, you have to be extra careful. I will explain why std move is very dangerous in my next video or in some future video. I will wrap up this session now. If you are existing audience, then you do not need to watch the rest of video. If you are new audience to my YouTube channel, please keep watching. I will post complete source code of this episode to extensiontalkplayfun.com website. If you click this button, you can download complete source code, and if you unzip it in the CPP extension tutorial subfolder, you can find the complete source code of this episode. Also, if you try to build by yourself, you have to install latest version of Visual Studio 2019. Please watch this video and install latest version of Visual Studio 2019. Also, I use GNU G++ and Clang on Windows. I highly recommend you to install GNU G++ and Clang compiler on Windows. Please watch this video and install latest version of GNU G++ and Clang. you also have to install Intel threading building block. If you watch this video, you understand what I'm saying. After installing these tools, you have to watch this video. By watching this video, you have to make command prompt like this, and also have to make proper system environment variable settings. Otherwise, you cannot compile my source code. So please watch these videos and make proper system environment variable settings. Then if you open CPP extension folder, then you can find tutorials folder. Please leave your questions and comments in the description section below. Please subscribe to my YouTube channel. Thank you for watching.